students. In the last lecture, we have discussed theoretically how the quick models are studied. Here today I am giving one example, one short example. The example is arrivals at a telephone booth are considered to be poison with an average time of 10 minutes between one arrival and the next. That means this sentence is giving the arrival fashion. Next, the length of a phone call assumed to be distributed exponentially with mean 3 minutes. Then, what are the questions? What is the probability that a person arriving at the booth will have to wait? That means we have to find the probability here that the system is busy. The system is busy. Second one, in the B part, what is the average length of the queues that form time to time? That means we have to find in this B part the expected length of the queue when the queues are formed. And the C part, the telephone department will install a second booth when convinced that an arrival would expect to have to wait at least 3 minutes for the phone call. And the question is, by how must the arrivals be increased? That means the telephone department will install a second booth. So what should be the arrival rate so that the telephone department will install a second booth? So here I will solve these three questions one by one. So arrival rate is solution. So in the question, the time between one customer to another customer is 10 minutes. So the arrival rate is lambda 1 upon 10. Arrival rate means the number of customers arriving in the system per unit time. So per minute. And the second one, the service for each customer is 3 minutes with mean 3 minutes. That means the mu, the service rate mu is 1 upon 3. That means per unit time. How many customers are being served per unit time? The first question is, so lambda and mu are known. Lambda is 1 upon 10 and mu is 1 upon 3. So my first question is, what is the probability that a person arriving at the booth will have to wait? That means in A part, the probability that the arriving customer will have to wait that means that is the probability that the system is busy. So we will compute here the probability that the system is busy, that means rho, which is lambda upon mu. So lambda is 1 upon 10 and mu is that the system is busy is 3 upon 10. That means 0.3. That means 30% is the chance that the system will be busy. Now the second question is, what is the average length of the queues that form from time to time? Average length of the queues that form time to time. That means we have to compute L such that L greater than 0. The formula is mu upon mu minus lambda equals to mu is 1 upon 3 upon 1 upon 3 minus 1 upon 10 is equal to 1 upon 3, LCM is 30, 10 minus 3, 1 upon 3 upon 7 upon 30. So it is 30 upon 3 into 7, 10 upon 7. So approximately one customer always exists in the queue. The third and the last question is, we have to find the arrival pattern so that the telephone department will install a second booth, or the condition for the second booth is that an arrival would expect to have to wait at least 3 minutes for the phone call. C part. So it is given that the telephone department will install a second booth when convinced that arrival would expect to have to wait at least 3 minutes. So for the phone call, that means average waiting time WQ is equal to 3 minutes. At least, that means if an arriving customer waits at least 3 minutes or more than 3 minutes, then the telephone department will install the second booth for the customers. So WQ is equal to 3 minutes. At least this 3 minutes is the least number. Since we know that the formula for WQ, lambda upon lambda mu minus lambda. Sorry, mu. Lambda upon mu minus lambda. So our aim here is to find lambda dash, that means the rate of the arrivals. This is equals to 3 is equal to lambda dash. Mu is 1 upon 3. We have already in the question mu, service rate. Service rate is 1 upon 3. Service rate is 1 upon 3. 1 upon 3, 1 upon 3 minus lambda dash. So after solving this, lambda dash three lambda dash 1 upon 9 minus lambda dash upon 3 by cross multiplication. By cross multiplication we have 1 upon 3 minus lambda dash into 3 lambda dash, or here is equal to lambda dash. So this becomes 1 upon 3 is equal to lambda dash plus lambda dash. 3 and 3 cancel out. So 2 lambda dash is equal to 1 upon 3. Lambda dash is equal to 1 upon 6 is equal to 0.16 approximately. Lambda dash is equal to 0.16. And since we know the given lambda is equal to 1 upon 10, which is 0.10. So it is given lambda, and this lambda dash, this arrival rate is found when the customer has to wait for 3 minutes. That means the increased arrival rate is lambda dash minus lambda is equal to 0.16 minus 0.10, means 0.06. So 0.06 is the increased arrival rate when